Have you ever wondered about the mysterious substance known as red mercury, its origins and how it's made? This elusive compound is a captivating enigma that has intrigued scientists and chemistry enthusiasts alike. Red mercury, which is seldom found in its pure form in nature, tends to be chemically bound to other materials, creating what we know as ores. The most prevalent of these is cinnabar, or red mercury sulfide, denoted as HGS in the world of chemistry. This intriguing substance is a product of complex geological processes. It's formed underground when warm mineral solutions rise towards the Earth's surface, driven by volcanic activity. These solutions then find their way into faulted and fractured rocks at depths ranging from a mere 3 feet to an astounding 3,000 feet. The allure of red mercury lies not only in its rarity, but also in the intriguing journey it undertakes from formation to discovery. As we delve deeper, you'll discover the fascinating journey of this elusive substance. Mercury has been a part of our history for thousands of years, dating back to the ancient Egyptians and Greeks. This intriguing element, a heavy silvery metal that is liquid at normal temperatures, was first found in Egyptian tombs dating back to around 1500 BC. The ancients likely used it for both cosmetic and medicinal purposes. Fast forward to around 350 BC, the renowned Greek philosopher and scientist Aristotle described how cinnabar ore, essentially red mercury sulfide, was heated to extract mercury for religious ceremonies. The Romans had a variety of uses for mercury, and they gave it a name that reflected its unique characteristics, hydrogyrum, or liquid silver. This is where we derive the chemical symbol for mercury, Hg. The demand for mercury took a significant leap in 1557 with the development of a process that utilized mercury to extract silver from its ore. This process represented a major technological advancement and positioned mercury as a crucial element in the world of metallurgy. In the centuries that followed, mercury continued to exhibit its versatility. In 1643, the mercury barometer was invented by Torricelli, followed by the invention of the mercury thermometer by Fahrenheit in 1714. Then, in 1828, a mercury alloy, known as an amalgam, was used for the first time as a tooth filling in dentistry. However, the toxic nature of mercury sparked concerns, preventing this new technique from gaining widespread acceptance. It wasn't until 1895, following experimental work by G.V. Black, that amalgam fillings were deemed safe, although the debate about their safety continued into the 20th century. As we moved into the 20th century, mercury found its way into many industrial applications, despite the growing concerns about its toxicity. It was used in batteries, paints, explosives, light bulbs, light switches, pharmaceuticals, fungicides, and pesticides. It even played a role in the production of paper, felt, glass, and many plastics. This was mercury's moment in the sun, but as we'll see in the next scene, this period of widespread use would not last. The 1980s marked a turning point in the story of red mercury, as the world began to recognize its harmful health and environmental effects. Prior to this decade, mercury was a common component in a wide array of products and industrial applications. It was found in batteries, paints, explosives, light bulbs, light switches, pharmaceuticals, fungicides, and pesticides. It was even used in the production of paper, felt, glass, and many plastics. However, as our understanding of mercury's toxicity grew, so did our efforts to minimize its use. In just a few short years, the use of mercury saw a significant decline. By 1992, its use in batteries had dropped to less than 5% of its level in 1988. Similarly, the overall use of mercury in electrical devices and light bulbs had plummeted by 50% in the same period. As awareness of mercury's harmful effects continued to spread, legislative changes followed. In the United States, the use of mercury in paints, fungicides, and pesticides was outright banned. Manufacturers voluntarily discontinued its use in the production of paper, felt, and glass. These steps marked a pivotal shift in our relationship with mercury, transforming it from a widely used resource to a substance to be handled with extreme caution. Yet, despite these changes, mercury has not been completely eradicated. Its production continues, albeit on a much smaller scale and largely confined to a few countries with more relaxed environmental laws. This is a stark contrast to the heyday of mercury use, when it was mined and produced on a large scale in countries around the world. Today, the production of mercury is limited to only a few countries with relaxed environmental laws, marking a significant shift in our relationship with this intriguing yet dangerous substance.